Parallel and perpendicular lines. Hopefully you remember from GCSE what happens with the gradients of parallel and perpendicular lines. If we call the gradient of line 1 M1 and the gradient of line 2 M2, then when the lines are parallel, the gradients are equal. In other words, M2 equals M1. And when the gradients are perpendicular, then one gradient equals minus 1 over the other gradient. So we could say M2 equals minus 1 over M1. So let's work through some examples. So when we're approaching a question like this, I would suggest the first thing you do is write down everything you can. So we're looking for an equation of a line, so we know it's y equals mx plus c. We know what the m's equal to. Because it's a parallel line, we know that m1 and m2 are the same, so it will be y equals 2x plus c. So because m2 is equal to m1, we can put the gradient of 2 in there. This just leaves us now needing to find the c, and we can do that by using the x and y value from the coordinate pair of the point that the line passes through. So if we sub in minus 3 for y and minus 1 for x, we can find out c, and then we simply place the minus 1 into this equation, leaving the y and the x, and there's our equation of the line. Bit more difficult with a perpendicular line. Same information, we have an equation and we have a point that it passes through. We know that the equation we can write as y equals mx plus c, but this time to find our m, it's not just a simple matter of putting the 2 in, it's the negative reciprocal of 2 we want, in other words minus 1 over 2. So we put that in, we get minus a half for our m. We also put in our x and our y as we did with the previous example to find out c. We get c as 4.5 or 9 over 2. And then we just simply put everything into the equation. Normally if you get an equation with fractions like this, you'll be expected to get rid of the fractions by multiplying through by a whole number, and in this instance if you multiply through by 2 you'll get rid of these fractions on the right. So we multiply the whole equation, the left hand side by 2 and all of the right hand side by 2. That gives us this here, and we sometimes might rearrange that to make it equal to 0. So we have an x term, a y term and a constant equal to 0. So to summarise, to find the equation of a straight line, if the gradient isn't given, we need to find it either by using parallel lines and the fact that m2 equals m1, perpendicular lines and the fact that m2 equals minus 1 over m1, or use 2 points on the line using the formula that we learnt last lesson. We can then substitute y, m and x into the equation y equals mx plus c to find the c value and write out the equation. Okay, time for you to have a go. If you are okay with these questions and you can work through them reasonably comfortably, then you'll be ready to move on. If not, if you're struggling with them, then go back over the video, or if you prefer, have a look at this topic in the textbook, work through some examples, or maybe on My Maths. When you're ready, then go through the solutions. So pause the presentation now, have a go, and then the solutions will follow. Right, first solution. Well, the first problem we've got here is we don't have an equation in the form y equals mx plus c, so we'll rearrange this equation to make it in that form by simply subtracting 2x from both sides and adding 1 to both sides, like so. We now know that the gradient is -2, and as it's a parallel line we're looking at, we know that has a gradient of -2 as well. We now use the x and the y value from our coordinates of the point that the line passes through to find c. We get c as 1, and then we rewrite the equation like so. Okay, the second solution, well, this time we've got a perpendicular line. We have a similar problem in that we need to rearrange the equation. We end up with this equation here, giving us a gradient of -1/2, which sounds awkward, but actually, as it's a perpendicular line we're looking at, we want the negative reciprocal of -1/2. In other words, we want -1 over -1/2, which is 2. So it's actually quite straightforward. We know the equation is y equals 2x plus c. We can use 1, 2 as our x and y value to find c. So 2 for y and then 1 for x gives us c as 0. So the equation is y equals 2x. Okay, last bit. A second formula for a straight line. This is really useful. You'll find this formula very useful throughout AS and A2 maths. You may find it's the formula that you will use the vast majority of the time. To derive the formula, we can look at xy as being any point on a line. We can make a fixed point on the line, x1, y1. And for any point, we can find the gradient by looking at how much it goes up or down. So how much the line between these 2 points goes up or down, in this instance up, for how much it goes along in a positive x direction. And this is what we knew from the work we did last lesson. So here we get y minus y1, x minus x1. So the amount it goes up in relation to how much it goes across is y minus y1 over x minus x1. If we rearrange this equation by multiplying through by x minus x1, we end up with this equation here. And this is a really useful equation for finding the equation of a straight line. I'll show you an example. So to use the formula, we either need 1 point and the gradient or 2 points on the line. Given 2 points, we find the gradient first using the formula we learnt last lesson, like so. We get a gradient of -2. If we then put that into this formula using either of these 2 points, so either use that x with that y, or alternatively that x with that y, well, we'll use the first 2, put them in, and then we simply rearrange this to get our equation of our line. We don't need to work out c, it comes out using the formula. And a lot of people find this a lot more friendly, a lot easier formula to use than y equals mx plus c.